Hello guys, welcome to Placeboard to Edu and my name is Vinayakumar Nayan.
Today we are going to learn about the analysis of resistors part 4. In this I am going to explain you delta to star and star to delta transformation. So let's get started.
Coming to the transformation, many of the students will confuse in one thing, that is naming of the resistors in delta and star configuration. I am going to tell you simple technique to remember the naming and such that the formulas are also based upon that naming. Here I am going to name the terminals as A, B and C. Same here, A, B and C. Okay, now there is a resistance between A and B, so I'm going to name it as RAB, right? Similarly, I'm going to name this resistance as RAC and this resistance as RBC. Okay, and the next thing is, here a resistor is connected only to the terminal A, so this is RA, this is RB, this is RC. Delta to star conversation or transformation we are going to learn today. And the second point is, whenever you are transforming a delta circuit to star circuit, the star circuit should be drawn as stated. That means this terminal and this terminal should be coincide. Understand? So I have to draw it like this, and this one here, this one here. Naming them, this is RA, RB and RC. This is must and should. Many of the people will confuse and they may change the terminals, but this is what they have to do. Sometimes delta need not be like this, it can be like this. Understood? This is A, this is B and this is C. Since this is a conductor, this total is C. Understood? So for this circuit I have to draw star like this: RA, RB and RC. This is RA, this is RB and this is RC. Understood? These are the rules you should follow while transforming delta to star. That's nice. Okay, then what is the formula? And here also there is a difficulty in remembering the formula, so I'm giving you the technique to write the formula. Whenever we are converting or transforming delta to star, which means the blue color resistors are the resistors which we know the values. Okay, so we have to convert into this white color resistors. So RA, RB, RC are the values we have to find while converting from delta to star. How can I find the values? At RA, that is the terminal A, at RA we have two resistors connecting the RA resistor. One is RAC and another one is RAB, right? So we have to write the product of the two resistors, RAC into RAB, as numerator, and for denominator we have to add all the resistors. Understood? So what I have to do, I have to add all the resistors. RPC, this is RA. It is clear, I think. Whenever we want RA, we have to write the product of resistors for which RA are connecting, RAC and RAB. That should be the numerator, and the denominator is sum of all the resistors, not remaining, the one should be included. So RAC plus RAB plus RBC. Understood? In this way we can remember the formula. Okay, so if I consider all RA, RB, RC, so this will be the, see here, these will be the values RA, RB, RC. Here this is delta to star and this is star to delta. We'll be discussing it later, but see here RA, RB, RC and RAB, RBC, RAC, RBC. In this way we are going to transform delta to star. Okay, how can I transform star to delta? Again the same thing, I am naming the terminals A, B, C, and here also A, B, C. I have to give the names for resistors. This is RA, this is RB, and this is RC. It's clear, right? I've already told you how to write. This is RAB, this is RBC, and this is RAC, right? So whenever I am converting star to delta, the delta should be drawn only like this, that is in between A and B it should be RAB. That's very important, because whenever we are converting star to delta, this is a simple circuit, but whenever in complicated circuits you may be confused where RAB will be. We will be going to solve the problems and then you will get clear understanding why we have to write only like this. So here it should be RBC and here it should be RAC. Nice, right? Now the pink color resistors are the resistors we don't know the values, right? So we have to find them. In order to find RAB, what I am going to do is, see here, for RAB, RA, RB are like connecting, but RC is not connecting. I'm just giving you the technique to remember the formula. That's it. There is nothing rocket science in this. Okay, so RC is not connecting. That means if this is the resistor which we have to find, the opposite resistor will be the denominator. So here this will be RC. What will be the numerator? Numerator will be common for all resistors, and that will be the product of individual resistors, that is RA into RC plus RB into RA plus RB into RC. Whatever may be the order, but this is the thing what you have to remember. What we have to remember is the resistor which is opposite to this will be the denominator. That's the thing you have to remember. Okay, so now see here RAB, RBC and RAC. What is RAB? The resistor which is opposite to RAB, that is RC. This is very important. The resistor which is opposite to RBC is RA, and a resistor which is opposite to RAC is RB. This is clear, right? So what is the thing you have to take from these formulas is, always products are in the numerators. So see here, what is the rule? The products must be in the numerator. I think you understood how to convert star to delta and delta to star. I am not concentrating on the formulas, but I am concentrating on how to remember them. Okay, so now going to do the problem which we have. See here, this is 10 ohms, this is 3 ohms, this is 3 ohms, and this is 10 ohms, this is 3 ohms, this is 10 ohms. Now if you observe clearly, we have a star very clearly, right? This is a star, very clear. But why I am doing a conversion from star to delta? Can't I solve this problem using series and parallel circuits. No, we can't solve. You can check it by seeing my previous videos. Are there any series pairs of resistors or parallel pairs of resistors, and then you can do this problem. So this is a star, or else what you can do is you can also consider this delta or pi network. See here, you can also consider, but considering this 3 ohms 3 ohms 3 ohms star will be much easier than considering a 3 ohms 3 ohms 10 ohms delta. Why it is difficult to consider this delta, I am going to tell you in a while. But considering this 3 ohms 3 ohms 3 ohms star, what I have to do is I have to convert them into delta. Understood? So now I am naming the terminals. That is must and should important. That is must and should, because if you become a pro in this, then no need to name, but you have to name it. So A, B and C, I am just naming them. Now after naming, I have to draw the resistors of delta connection. So this is a resistor RAB, understood, between A and B, and this is a resistor RAC, and this is a resistor RBC. Nice, right? So after converting the star to delta, you can see this 10 ohms and RAB are parallel, and here 10 ohms and RAC are parallel, 10 ohms and RBC are parallel. So the main aim of star delta or delta to star transformation is we are simplifying the network such that we are getting parallel or series connections. Understood? So you have to be thorough with series and parallel connections of components in networks. That's what I'm saying. Okay, now what is RAB? RAB is nothing but RAB, the one opposite to RAB is C. So I have to write here C and all the products of them. So RA into RB and plus and so on like that. So RAB is nothing but 3 into 3 plus 3 into 3 plus 3 into 3 by 3. So what it will be, RAB is equals to 9. Understood? You can solve it. RAB is equals to 9. So we have RAB is equals to 9, and this will also will be 9, and this will also will be 9. So the important conclusion what you have to remember here is, whenever there is a star with R as resistor converting into delta, then the resistors in delta, this is R star, let it be R star. So the resistors in delta, that is R delta, will be 3 times of R star. This is the important result which you have to remember. This is an important result. But there is a condition regarding this. Here resistances should be equal. Understood? This is the important condition, but where the resistances should be equal. That's why what I did is I consider this triangle, sorry, I consider this star which is of equal resistors instead of considering this 3 10 ohms. So I got very easy solution by considering the equal resistance star. So we have 10 ohms and 9 ohms parallel, 10 ohms and 9 ohms parallel, and 10 ohms and 9 ohms parallel, which we can solve it further by considering the parallel circuits and series circuits. I'm not here to say you the parallel and series circuits, but I'm just telling you the importance of converting star to delta or delta to star. Hope you guys understood this. If you have any doubts, you comment in the comment section.
Hope you guys enjoyed this video. So please like, share comment and subscribe. If you guys didn't like this video, please let me know through comments. Thank you.